The value of a piece of factory equipment after 3 years of use is 100 times 0.5 power x, where x has the MGF 1 over 1 minus 2t. Find the expected value of this equipment after 3 years. So we already know that this is the expected value after 3 years. So there is no like substitution of time equals 3 anywhere. We already are given that this is a 3-year value. So we have to find the expected value of this expression. Expected value of 100 times 0.5 power x. Now, the key here will be, see, the only thing that is given to us is the moment generating function. And if we write expected value of 100 times 0.5 power x, there is nowhere to go unless we make use of the moment generating function, because nothing else is given. So by definition, we know that moment generating function mxt is equal to expected value of e power tx. So remember this equation, we will need it in a while. So we are to find expected value of 100.5 power x, and the 100 can be pulled out because expected value of ay is equal to a expected value of y always. And so 100 is pulled out, and now this is expected value of 0.5 power x. Now we would like to write this in this form so that we can make use of the moment generating function. So this is e power tx. So you have to write this 0.5 power x somehow as e power something times x. So because that t is the argument that appears over here. So x has to be maintained, and we need a coefficient of x besides. So the only way we can go about this is that we write the 0.5 power x as e power ln 0.5 power x. And the reason why we can do that is that you know that whenever you have e and power ln, they kind of cancel out, and the result is whatever is left over, which is 0.5 power x. So that's why 0.5 power x is equal to e power ln 0.5 power x. So now, using the log property, this x in the power can be brought as a coefficient, and so it would be e power x ln 0.5. And now if you compare this with 1, 1 is e power x times t. This is e power x times ln 0.5. So ln 0.5 is playing the role of t. So therefore we can say that this is equal to mx of ln 0.5, because mx of t was e power tx here. So mx of ln 0.5 would be e power ln 0.5 times x, which is what this is. So we just now need to calculate the moment generating function at ln 0.5. We have the general expression at t, it is 1 over 1 minus 2t. So at ln 0.5, it will be 1 over 1 minus 2 ln 0.5. Substitute ln 0.5 in place of t, and that gives 41.9, which is choice C.